Good afternoon, ladies and gentlemen, and welcome to the penultimate session of TechEd 2011 Atlanta. It's been good for you? Yeah? It's been great fun being here too. I've really enjoyed it. And this is a great room to have this session in. I just can't work out if it's an IPv6 or an IPv4 echo. But we'll find out. Just to give you a little bit of background, I work out of the UK, so you can probably tell if you haven't heard my accent before. And I specialize in infrastructure, and one of the things I really enjoy doing is getting involved in sort of TCP/IP and all those sorts of things. This session is seriously level 400. So if you came along to just have a beginner's look at DirectAccess, it's probably not the session for you. We're going to go really deep, and we're going to be doing some serious sort of investigation work as to what's going on. How many of you like troubleshooting networks? Okay, just a few. Well, we're just going, this is extreme troubleshooting, extreme pinging. Must be why the echo is on. And how many of you don't like troubleshooting networks? No one. Well, oh, one person at the back. Well, this session's definitely for you, because if you actually follow all the things you're going to learn in this session, you'll shorten your troubleshooting time, and therefore it'll be good for you, so you won't have to spend so long doing it. Okay, so what am I going to cover? I'm really going to cover all the components of DirectAccess, but from a troubleshooting aspect. So we're really going to delve down into exactly what's going on. I'm not going to teach you all about DirectAccess, but what I want to do is get you to take a troubleshooting approach. So something doesn't work. What do you do to start with? How do you approach it? Very interestingly, yesterday, someone came up to me in the exhibition hall and said, yeah, you're doing troubleshooting DirectAccess. Can you tell me how to do it? And I said, well, come on the session. He said, no, on my laptop now. And we went through pretty much what I'm going to show you. Actually, it's almost one of my demos. And we went through it, and within 10 minutes, we had him connected back to his corporate network. And what I'm going to do is really sort of trying to get you into the correct philosophy for working with this. And my mouse has gone distinctly asleep. Oh, well, never mind. We'll use the keyboard here. And I've gone the wrong way. Let me use this. Okay, so I like to draw this thing of DirectAccess being a VPN on steroids. So as soon as you connect your computer to the network, right, the internet, the home network, working in the internet cafe, we immediately build an infrastructure tunnel that takes you and connects you to CorpNet. And you could leave it at that. And that is one of the modes of deployment of DirectAccess. And the reason for doing that is so that you can manage out. So we can actually manage that client out. As soon as the client logs on, and we've configured it for this, there will be another tunnel constructed. And that's referred to as the infrastructure tunnel. And through that tunnel, they gain access to the corporate resources. I like to think of this as not being a VPN which connects a user to the network. I like to think of DirectAccess as taking your corporate network out and grabbing the remote systems. So you're almost integrating them in with your network itself. It's end-to-end IPv6 from a client perspective. The client has to talk over the IPv6 stack. Of course, the reality is what's actually transported over the internet is probably going to be in IPv4. Right, so we need tunneling technologies to do it. But one of the things you need to be very, very careful of is, if you're deploying DirectAccess, is making sure your apps work over the IPv6 stack. Now, on the server side, we can do some slightly different things. But on the client side, it must go over the IPv6 stack. I'll talk more about the server in a moment. Simple? Well, maybe not. You see, the problem is, we need to know where that client is. And there's really three flavors of internet connection. We can be connected directly onto the internet. And by being connected directly onto the internet, I mean you have a public IPv4 address. We could be connected behind a NAT device, and we would use a different transition technology to come in depending whether we're on the internet or behind a NAT device. We could be behind a NAT device where UDP 3544 is blocked, in which case we fall through to the secret weapon, and the secret weapon is to put IPv6 into HTTPS. Right? So HTTPS, I would say 99.9% of the time you will get through. So everyone needs it on the internet. So if you're sitting in an internet cafe, sitting in a hotel, etc., there's probably almost 100% chance you'll be able to use HTTPS. And that's our sort of get out of jail card. So if we can't connect for some reason, even if we're connected directly on the internet, right, we may find that the actual IPv6 goes into IPv4 using Protocol 41. Protocol 41 may be blocked, and therefore we can't do that. So what do? We fall back and use a different transitioning technology. We won't use Teredo, which works behind a NAT device, but what we'll do is we'll fall back and use IP HTTPS. We need to encrypt the traffic. All right? So the traffic coming in across the internet will be encrypted, and we may decide to encrypt or authenticate the traffic on our corporate network as well. And then the client has to figure out, am I on the internet or am I actually inside CorpNet? Because what the client will do is it will make decisions around DNS based on where it is. And all of these little components come together to create a troubleshooting nightmare. How many of you have run the DirectAccess wizard? Fantastic. It's probably about a third, maybe sort of moving, yeah, about a third of you, I think. And step 1, step 2, step 3, step 4, did it work? How many of you did it work for first time? Yeah, okay, so that was probably, I don't know, 15, 20 hands the first time and 4 hands the second time. And the question is, what do you do? Well, what I want to do is show you how we can think about the troubleshooting aspects. That's my troubleshooting environment. I have a home network, if you don't want to call it a home network, internet cafe, hotel, whatever you want to think about. And that's basically sitting behind a NAT device. I then have the internet, and then I have my corporate network. And I'm going to be working in this environment. Now, if you've got an IPv4 only resource inside your corporate network, and what do I mean by an IPv4 only resource? It could be that you only have an IPv4 stack, so you haven't got an IPv6 stack at all. That would definitely be an IPv4 resource. Other resources, such as Windows 2000, you can put an IPv6 stack on it, but Windows 2000 built-in utilities do not work. All right? 2003 and XP built-in applications are considered not to be IPv6 stack compatible. So file shares, sort of domain controllers, and all the other bits and pieces. Microsoft drew a sort of line and said, look, some work, some things work, other things don't work. So what we'll say is they don't work. Right? So the best way, obviously, is to do an upgrade path. And if you want to come in, you talk to 2008 servers, 2008 R2 servers. Alternatively, we can use a translation mechanism such as NAT64, which combines with DNS64 to take the IPv6 packet, take the data out of it, and transport it inside our corporate network directly in IPv4. So that's what NAT64 does. It has to be combined with DNS64 so that we can actually spoof the client to think it's talking to an IPv6 end. So at the end point, as far as the client's concerned, it's got to be IPv6. So before you deploy DirectAccess, what you absolutely must do is make sure that all the applications you want to use are IPv6 stack compatible. Here's a sort of connection summary. So, if we question. Sorry, Was it UAG had the... Yeah, so if you use UAG, built into UAG is NAT64 and DNS64. And in which case, you can then talk to a 2003 server, and you would talk to it using IPv4. And so at the edge, you effectively take the data out of an IPv6 packet, and it goes into an IPv4 packet. So that's what NAT64 and DNS64 does. It comes with UAG, so forefront UAG. You can't get it any other way from Microsoft. There are actual network appliances which will do the same functionality, but actually if you look at the cost of a hardware appliance against the cost of deploying UAG, right, there's very little in it. And if you are seriously working with DirectAccess, you want to deploy DirectAccess on UAG, right, because you can deploy it on a single Windows server. The problem is it's not load balanced, it's not fault tolerant, because if you lose it, you lose the connection. So if you're deploying DirectAccess in an organization, it is really a UAG device you need. Okay, so if we're coming from the IPv4 internet with an IPv4 public address, it will use 6-4 if it can, right? If it can't, it will fall back and use IP HTTPS. If we're coming from behind a NAT device, it will use Teredo if it can. So 6-4, we take an IPv4 packet, we put it in, we take an IPv6 packet, we put it into an IPv4 packet, protocol 41, send it on its way. With Teredo, what we do is we take an IPv6 packet and we put it into UDP and send it to port 3544. If we're behind a NAT device and Teredo doesn't work, it will fall back to IP HTTPS. Right? You don't, if you're behind NAT, you obviously can't use 6-4. 6-4 only works if you have a public IPv4 address. But the fallback is always IP HTTPS. So we've got to make sure that that really works. Now, looking at that, you say, well, actually, hang on. You can come from a public internet. You can come from behind a NAT device with IP HTTPS. Why don't we use it? The problem is you've got double encryption. Because what we've got is the IPv6 packet, which goes inside an IPsec tunnel, which then goes into IPv4. So if we take that IPsec encrypted tunnel and we put it into HTTPS, we've effectively got a double encryption. Is it doubly secure? No. All right, but it is a double overhead. So that's why IP HTTPS is the least preferred. We then reach the edge, and there I'm showing full-front unified gateway. And we're going to take the IPv6 out of however it's got there, out of IPv4, out of UDP, out of IP HTTPS. Now it's inside the UAG server. If we're going to an IP4 only resource, we'll use the DNS64, NAT64 to take the data and put it into IPv4. If we go out of over native IPv6, which is the preferred, we just route the packet out over IPv6. And the alternative is to use another transition technology called ISOTAP. And ISOTAP, in some ways, is very similar to 6-4, that it simply takes the IPv6 packet and puts it into an IPv4 packet, and using protocol 41 again. So there's a lot going on there, and there's a lot of potential places where things might not work, and that's where you have to do your troubleshooting. Now, if we look at securing the tunnel, the tunnels are actually secured with IPsec. Right? This is an IPsec tunnel from the client directly to our edge, so to our UAG server. The tunnels get terminated on the UAG server. And there are actually two tunnel endpoints, and we'll talk more about those later. So what we've got is the infrastructure tunnel, which is where the computer talks to things inside CorpNet that it's allowed to, and then we have the intranet tunnel where the user comes through. Both those endpoints have to be terminated, and they're terminated on the UAG server. In terms of authentication of the infrastructure tunnel, both tunnels actually use dual authentication. The infrastructure tunnel, number one, is authenticated with a computer cert. The next thing it's authenticated with is a user, which in this case is the computer account. So if you look in IPsec, it will say user, but it is actually the computer account. So what you'll see is whatever the computer name is, $, which represents the computer account. So that's how we authenticate into the infrastructure tunnel. In terms of the intranet tunnel, the first thing is the computer cert or a health cert. So if you ran NAT, network access protection, what we would do is check the health of the client through the infrastructure tunnel, so the first tunnel that comes up. If the client's healthy, we issue a health certificate to the client, and then when it brings up the intranet tunnel, it's authenticated using the health certificate. So if you ain't healthy, no health certificate, the tunnel doesn't come up. All right? The next authentication is the user, and the user can come in either as the user itself, smart card, or I should have put on there, also now we have one-time password capability with UAG with the service pack on it. Got a little IPsec primer, because if IPsec doesn't work, it's probably pretty clear we ain't going to get in. We get in to some extent, but we will not bring up the tunnels. So IPsec, the concept of it is we're going to encrypt, and we're going to encrypt and authenticate. And when I'm talking about authentication, this is at network level. So if you imagine that you're actually, just forget DirectAccess for a second, if you decide to use IPsec between a client machine and a file server, we will have the authentication at network level, and then you'll have the authentication at session level, which would allow you access to the file shares. So here, we're talking authentication at network level. So if you don't get authenticated, you don't get network connectivity. So we need a shared secret, and we need a way of exchanging a shared secret between the two parties. So the client out there, the UAG server. And what it does is it uses an algorithm called Diffie-Hellman, which has been around for years, and it's a very, very clever algorithm. And what it allows you to do is actually establish a shared secret with actually not passing it over the wire. And if you want to look up Diffie-Hellman, just go on Google. So I was going to say Google, it should be Bing. Just go on Bing and have a look, and you will find lots of references to it. You don't need to know how the protocol works. Exchange a shared secret. That takes a little while to negotiate, right? And here we're talking a few milliseconds to negotiate. So we don't want to keep negotiating. So what we do is we use that as what we call the main mode channel, or the main mode security association. And we establish this main mode security association, which now gives us a secure channel. And through that secure channel, we can swap session keys. So if we want to start encrypting data, we create a session key, we swap it across the main mode channel, right, which is very, very quick. We just pass it up the wire. It's secure, so that's absolutely safe. And then what we do is we encrypt and decrypt the data with a symmetric key, right? And you don't want to send too much data with a symmetric key that stays the same. So what we do is on a very regular basis, change the key. By default, it has a 1-hour lifetime, all right? Or every 100 megabytes of data, it gets swapped. So as you're sending more and more data, the key gets changed. And you know, if you're security conscious, you can sort of go, oh no, I want it swapped much more often than that, and I want to have a much shorter lifetime. Top one stays in place for an hour. The lower one is, as say, it's the default before a key swap is 1 hour, 100 megabytes of data, and it gets dropped after 3 minutes of inactivity. All right? If you don't have a main mode, you are never going to have a quick mode association. All right? So if things are not working as we expect, this is a place that we need to look. Once we've swapped those session keys, then the data exchange takes place. And as far as the tunnel's concerned, we are always going to do, across the tunnel, we're going to do integrity and encryption. You have the option in DirectAccess of saying, I want to go from this client all the way to this server in here, and I want to check, I want to authenticate with IPsec against this server. That is one of the deployment options. And that can be in the clear, but we do the authentication. Or you can go all the way from the client, fully encrypted, to the target. If you're doing that, these need to be 2008 servers. All right? I should also say that if you're managing out, so if I've got a client connected through and I want to manage out to them, this guy has to be 2008, 2008 R2, or Windows 7 to do the management. Right? And you have to be running, obviously, the IPv6 stack. So we have to go out over IPv6 if we want to manage out. OK, if you want to see these as security associations, the simplest way of doing that is to use Windows Firewall with advanced security. We can also look at them using NetSH. The main mode is there, we're just showing it. And what we can see on the main mode is that we've got here, the first authentication is computer certificate. The second authentication is user Kerberos, and it tells us who it is. By the way, if it's using NTLM, all right, it will not show you who the person is who's authenticated, but you can look at the security logs to see who's actually logged in. And why would it use NTLM? Well, if you imagine you're trying to bring this infrastructure tunnel up, all right, your domain controllers are inside CorpNet. We need to bring the tunnel up. We can't go through the tunnel to get a Kerberos token, all right? So what we have to do is come to the tunnel endpoint, and the tunnel endpoint authenticates us via NTLM. So we've now got the tunnel up for the computer. The user always comes through the infrastructure tunnel when logging on. The user cannot get through the tunnel until they can get authenticated. So the user on the infrastructure tunnel also gets authenticated with NTLM. As soon as they've been authenticated on the infrastructure tunnel, they can go through the tunnel to a domain controller, request a Kerberos ticket, and then they can come through the intranet tunnel, authenticate to the end of it using Kerberos. So don't think things are wrong if you see NTLM. The infrastructure tunnel endpoint will be NTLM authentication. But once we can come through the tunnel to our domain controller, then we can come back through the intranet tunnel and authenticate with Kerberos in the end. So that's main mode. Quick mode, if you see it, you'll see a security association there. I suppose to just mention it, it's integrity, it's encryption. Why? Because it's a tunnel, and you always have encryption on the tunnel. That's the whole point of the tunnel. So when you run the DirectAccess wizard, what it actually does is it does a number of things. But first of all, we need certificates. On the DA server, there will be an IP HTTPS certificate. That's for terminating. So an SSL cert will be needed for terminating the IP HTTPS connection. We will then need a root or an intermediate certificate to validate client certs. That is not good enough just to be loaded in the store. We actually have to load that into UAG. I'll talk more about that later because that is a troubleshooting issue and area. You run the wizard. And what the wizard will do is it will configure all of the tunnel and transition endpoints on the UAG server. So it puts in 6 to 4, so clients coming off the internet. It puts in Teredo, clients coming from a NAT device. It puts in IP HTTPS. So those are the tunnel endpoints for the internet. And then what it does is it will put in ISOTAP for you, which will allow you to transition IPv6 over IPv4 in your corporate network. And then it'll also put in DNS64 and NAT64. All right? So having done that, it creates some group policy. And it will create a group policy for the client. And for the client, what it does is it does all the transition technologies on the client. It sets up NRPT rules, which is Name Resolution Policy Table. Again, I'll come back to it on the client. And it sets the IPsec rule on the client, so how the client uses the tunnel. And then we run it also creates a group policy, and inside the group policy that is applied to the UAG server are just the IPsec rules. There's nothing else in there at all. So it's the IPsec rules for the end of the tunnel. And then if you decide that actually what I want to do is go all the way from a client out there, all the way into a server there, using IPsec of some sort, then it will need to create a group policy that gets applied to those servers. Now, I don't know if you've used DirectAccess on Service Pack 1 of UAG. The group policies used to just be made with right up at the top level, and they were security filtered. You can now name your group policies, and you can apply them at OU level. So there's a lot more flexibility with these policies. Now, the good news of this is that the wizard normally gets all of this configuration right. Where things go wrong is where we, as administrators, make mistakes in terms of setting things up properly. A lot of the troubleshooting is really around misconfiguration. I have never seen the wizard create the wrong IPsec rules, for instance. So as long as you've got pretty good confidence that those group policies are going to be good, right? And what we need to do is just come up with a troubleshooting philosophy to be able to work our way through and find where the problem is. So, troubleshooting. Rule 1, no SA, no security association, no IPsec, all right? ICMP v6 is exempt from IPsec. So ICMP v6 should work, all right? We should be able to ping using IPv6. You use NetSH to check the state of the transition technologies. So if you were on, for instance, the 6-to-4 network, you would expect the 6-to-4 tunnel. Sorry, if you were on the public internet with a public IPv address, IPv4 address, you would expect the 6-to-4 interface to be enabled. Right? If you were behind a NAT device, you would expect the Teredo interface to be enabled. So we can go through, and using NetSH, we can check all of this. You can check the IPv6 configuration with NetSH, the IPsec status. You can basically check everything. This guy becomes your new best friend. So how many of you use NetSH? Okay, so quite a number of people. I'd say half the audience. It's great. You can look really geeky using NetSH, especially if you just remember all the rules. But it's very well, there's a lot of help in there, and you can drill down and actually get examples of help. So I want to start off. I have Windows 7, and Windows 7 is sitting out on the internet. It's got a public IPv4 address. So which interface should be alive? 6-to-4, okay? And for some reason, I cannot get to my corporate resources. And what I need to do is go through and look at a way that we can actually troubleshoot this. So I'm starting off, and we'll start off on our Windows 7 and get the Windows 7 experience. Here we go, look at that. And you go, oops, doesn't work. That resource, da-at1.corp.examples.com, is on my corporate network. So what I'm going to do is just grab this, and we'll try a ping to it. So I bring up a command prompt, and just stick that at the top. And we're going to do a ping, and drop that in. Go on, that's it. Just trim it up. Obviously, we don't ping an HTTP address. Right, haha. Okay, it seems to be a DNS problem, that we've got a DNS problem here. So next job is we better do a ping to something we know is on the internet to make sure we've got internet connectivity. So crl.example.com is there. And when I say internet, all I really mean is a public IPv4 address. All right? So yes, we've got connectivity. So it's not a sort of connectivity problem in terms of our IPv4. So that looks good. So what's going on here? Well, what we should do is an ipconfig. And we do an ipconfig/all. And let's scroll up. OK, so we have an address. It's 144.19.204. That is a public address. And what do I mean by a public address? It's just not one of the private address ranges as defined in the RFCs. So the 192, the 10 address, and so on, the ones that are we use for private address space. So let's scroll down a bit, and we should find our 6-to-4 adapter is enabled, and it is, which is great. And what's more, we have an IPv6 address for it. So there's our address. So 2002 is always the start of the 6-to-4 address. That lot there and that lot there are derived from our IPv4 address. And just for the fun of it, what they do is you take your IPv4 address and they convert each byte, or if you want to call it an octet, into a 2-digit hexadecimal number. All right? So there is one. Imagine you've got a dot there. There's the next one. You've got a dot there. There's the next one. You've got a dot there. And the last pair of digits. Now, if you need to do a check, it's very, very simple. The first digit represents the number of 16s, and the next one is the remainder. So who's going to do 9 times 16? Anyone? Anyone good at the 16 times table? I'll give you a clue. 9 times 16 is 144. All right? 144. Plus 0. Anyone want to do that one? 144 plus 0? OK, 1, 4. I'm not very good at writing with a mouse, but it'll do. Dot. 1 times 16. 16 plus 3. 19. All right? C, it's hexadecimal. So A is 10, B is 11, C is 12. 12 times 16 is 192 plus 8, all right, which gives us our 200. And the last one is really easy. It's 0 times 16, which is 0, plus 4, which is 4. So 144.19.204. So you can actually, if you need to just check that it's actually the correct derived address, you can actually do that. So we have a DNS server there, and we also have a default gateway. OK, so the next job I want to do is I want to actually use NetSH to look at my interface. It is alive, but if it wasn't alive, we could do a check to look at the interface itself. And of course, to do that, what I'm going to use is good old NetSH. And I'm going to look at the interface, and it's the 6-to-4 interface. And here, I'm going to show state. And it's showing default state. Default state is what it should be for Windows 7. By default, it's on. And we can see that it's actually on there. Now, what happens with 6-to-4 is we put the IPv6 into a tunnel, and it's got to come out of the tunnel. Right? This is the transition tunnel. And it comes out at the relay. The relay, 144.19.02, is the first IP address of my UAG server. We always need 2 public addresses on our UAG server. That's the first one. So we can do a little bit more troubleshooting here, and we can ping that. And what happens? Not a lot. So what's the problem? Is it there, or could there be another problem? What could it be? Is there someone taking my UAG server away, or it could be blocked? Firewall. All right? Could be a firewall. Now, let's go back a little bit, and let's grab my default gateway. The default gateway is an IPv6 address. Let's grab that. And let's try pinging this guy. And by the way, if you're very observant, you'll see 144.19.02 is here. It's 90, which is 144, 19, colon, we don't need to put leading zeros, so it would be 0, 2. So that is actually this derived from this address. It's a 64 derived from the IPv4 address at the other end. Let's try that. And that's successful, so we can actually ping in. So what's the next thing we can look at? We can actually now ping IPv6 from our client machine into the tunnel endpoint on the UAG server. So that we saw we're getting a problem with DNS. But before I always like to do is, whenever we're working with TCP/IP, the client makes routing decisions. So I always use the routing table. And I'm just going to do NetSH interface IPv6, and I want to see the routing table. And there's my routing table. This guy up here, let's just do that. Anyone know what that is? Colon, colon, whack 0. It would be the same as if you looked at a routing table in IPv4 as 0.0.0.0, which is the default gateway. Yeah, well done. So that is my default gateway. There's the address, which ties in, so that looks good. And do I have a route to the 200 network? Yes, I do. Go out through the 6-to-4 adapter. Well, we didn't actually need to do this here, but it's a very good way. Do you actually have a route to the network you're trying to get to? Is the default gateway set correctly? We wouldn't actually need to do this in this case because we know we've got that connectivity. But I always like looking at the routing table to make sure how my clients are routing. Okay, so let's try something else. Now, DNS was failing, and what I can do is I can actually look at this thing called the Name Resolution Policy Table. I will explain this in more detail later. And this is actually telling the client how it should work with DNS. And what we've actually got in here is it's really saying here, if you're going to anything on CorpNet, use this DNS address down here. So that one there, right? And what it's using it for, so it's now resolving based on namespace. This thing up here, this is corp.example.com, so anything for corp.example.com, use this DNS server. Up here, this is an exception. It's saying, if you're going to nls.corp.example.com, use this DNS server. And there's no entry. And what it means is use whatever your IP configuration is on the network adapter. So if we're trying to get to nls.corp.example.com, we'll use whatever the IPv4 DNS is. But if we're going inside CorpNet for everything else, we will use FD009999. So if you've actually done any troubleshooting on this yourselves, what you'll probably see is this address would begin 2002. The default is that UAG derives everything off of 2002, a starting point. I've actually got an IPv6 network inside CorpNet, which is actually beginning with FD00. So let's have a go. Can we ping this guy? Yes or no? Yes, we can. So we actually can ping the DNS server. Now, I happen to know that I have an application server inside CorpNet. These guys are inside CorpNet. There's my application server, and I can ping it. Now, DNS is running on a domain controller. So let's NetView. And it fails. So what we've proved is that we've actually got connectivity from the client using IPv6 to the UAG server. We came to the default gateway. We've now gone from the UAG server inside CorpNet to the DNS server. And I know I've got an application server sitting that other address. And that works. But I can't net view my DC. And I expect if I net viewed my DC to at least have the net logon share, probably a little bit more than that. So what's the problem? Sorry? We don't have authentication. All right, good. So let's rather than the authentication piece, we haven't got IPsec. If you remember on the slide, it said ICMP v6 is exempt from IPsec. Right? Everything else has to come up in an IPsec tunnel. All right? So authentication could be the problem, or we could have some other problem. But basically, no authentication. Well done. Great answer. So what we should do is actually have a look to see if we've got any security associations. So here, we use Windows Firewall Advanced Security. And what we're looking for is under the monitoring security associations and main mode. There aren't any. Quick mode. There aren't any. Well, I didn't expect to find any quick mode. If you don't have a main mode, you won't have quick mode. So something is wrong. So what we can do is we can actually go across to our UAG server, and we can have a look in the security logs. By the way, the times are all wacky on these machines because they've all been set at a particular time to get these faults to appear. So nothing in the security log. And that, if you want IPsec stuff to appear in the security log, you need to use audit poll to actually turn on subcategory auditing on IPsec main mode and IPsec extended mode. So I'm going to do that. And we'll just drop that into a command prompt. And that's turned it on. And what I need to do now is actually, we need to force it to work. So I'm going to go to my Windows 7. I'm going to disconnect it from the network and then reconnect it. And what that will do is it will force it to bring up the infrastructure tunnel. So just disable it, enable it. If I'd waited, it would have happened, but I just forced it. Okay, let's do a refresh on here. And we have a failure. So we've now got a failure, and it's an IPsec failure. And if you look at it, the local endpoint, all right, is now, if you've been very observant, do you remember the default gateway ended in a 2? All right, you may have seen that. This is actually the second IPv6, or the second IPv6 address derived from my second IPv4 on my UAG server. And this is where the infrastructure tunnel terminates. So the endpoint is to the infrastructure tunnel, and it's failing. All right, we can see where it's coming from, so this might be useful information as well. So that's from my client machine. And it's unknown authentication, remote computer, IKE authentication credentials are unacceptable. Anyone like to hazard a guess what that might be? Certificate, a problem with a certificate. Well done. So could be. Right. Let's go and have a look at our certificate. And what we need to do is look at the certificate, and it will be the client certificate. So we go across and have a look at the client certificate. And before we do that, what I want to do is use something an awful lot of people don't know exists. There are troubleshooters, and there's one for DirectAccess. And there it is. Connect to a workspace using DirectAccess. So let's run the troubleshooter. So it's detecting problems, which is a good sign. And it's starting the network diagnostics, looking for problems in name resolution. sorry, let me, hold on one second. Let's just finish this. Okay. Sorry, the question? No, the network, so where does the network troubleshooting, this is the network troubleshooter built into Windows 7. There is another troubleshooting tool as well, which I will come to. So it tells me the DNS server isn't responding. Well, we knew that, so that's not terribly useful. Now, the really inspiring thing about this tool is sometimes when you run it a second or even a third time, it gives you a different result. So let's just try it a second time. It's nothing like consistency. So we'll try it and see if it gets it. Okay, a valid certificate was not found for this network. So it's telling us there's a problem with the certificate. It's just nice that it tells us the DNS problem the first time, and then obviously it learned the first time and that we needed more. Okay, so let's go look at our certificate and cancel out of that. And then we fire up MMC and add in the certificate snap in. And what I'm going to do is go to computer account, next on there, and finish it off. Okay, let's have a look at our cert. So we're looking in the personal store for the computer, and there it is. And the certificate has expired or is not yet valid. Well, it's been set up to have expired. So we have an expired certificate. So what we better do is actually go and renew the certificate on the client machine. And we can go and do that. So we just go, and I'm just going to move this guy onto my corporate network. I could VPN in at this point and make that connection. But I'm going to go across and onto DA Corp. And let's go get a new certificate. So we'll go back to our Windows 7 box, which is now on DA Corp, and tell it to get a certificate. And next on there. So it gets the Active Directory enrollment policy. PKI is so important you get it right for dealing with DirectAccess, IPsec, and so on. So if you haven't got a PKI at the moment, it's certainly something you need to think about. Everything is using certificates these days. Okay, so that's given us one. We've got the expired one, which is showing there, which is that one. We'll just delete it. Put our client back on to the other network. So we're going to need the client back on the internet. So over here, so settings again. So just using Hyper-V to do this. I'm going to go back on my internet. And we find it. There we are, DA Internet. And what we should find is everything is now working. Let's close that off. And we'll close that. And let's just simply go across to here, do a refresh. Yep, that's in place. And if we do a refresh on our security associations, we've actually got 2 main mode security associations, and we've got 2 quick mode. And most of the time, it's a misconfiguration, and you don't need to actually drill into the IPsec stuff. What you're really looking for is, do I have a security association? And if not, it's probably going to be a certificate. And there's the where we did the net view, and that all now works. So that's sort of what I wanted to do is try and get you to think about in terms of how we troubleshoot this beast in terms of actually going through the process. And despite the fact we may not be able to ping with IPv4, what we're looking for is pinging with IPv6 because it is an IPv6 transport, right, that we're taking across. There is the DCA, which Direct Access Connectivity Wizard, which I think is the guy you were asking, or not wizard, assistant, which you were asking about. This is, it comes bundled with UAG SP1 now. And it's an option in UAG. You can choose to deploy it. It gets deployed via group policy. So we set it up and use it via group policy. There's ADML files, ADMX files that we put in to actually do that. And I'm going to, the DCA is through group policy, we need to set up two things. Number one is we need to do a probe, and that probe goes to the tunnel endpoints. All right, so we would set up a probe to the tunnel endpoints. And secondly, we say where we're going to probe internally in our corporate network. So the probe to the tunnel endpoints is what I did. It's a ping. I only pinged to the default gateway, but I could have pinged to both tunnel endpoints, and that's what the DCA will do. So it will show you you've got connection to your UAG server. And then it'll do, if you want, a ping internally. So you set up a probe internally as a ping, which says, oh, I've got ping. But then if you have a probe, which is to a file share, all right, and that fails, immediate indicator that it's an IPsec problem. All right, so it's very useful. And what the user can do is send you back reports. So I'm not going to actually spend time on this. I just want to show you the, here, what we've got is the, having added in having added in the group policy, we get the direct access connectivity assistance settings that we can do. And there's a little installation guide, and it's very simple. Simply define the tunnel endpoints, which is your DTE test, and then define things you want to probe in CorpNet. And as far as from a user experience, it will say, you haven't got CorpNet connectivity, and it will generate a log, and it will give you the results of the probes, it will give you all your IPsec settings, it will give you certificate settings, and so on. And it's not expected that the user consumes that, they send it off to the administrator. Okay, now in terms of certificate requirements, what we have, if we're using IP HTTPS, we absolutely 100% need a SSL cert. That's got to be that. And any CRL distribution points you publish in that certificate must be available to the client. Right? The simplest thing to do is to buy a public certificate, because then you know the client will trust it, and you know the client will be able to get to any CRLs, as in certificate revocation list distribution points, because they will be publicly available on the internet. If you decide to use your own certificates, and you can do that, and what you'll have to do is make sure that your CRLs are available to that client. And it only has so we need to make sure the distribution lists are available, or the certificate revocation lists are available. The other thing we have to do is that we actually have to make sure that we have a client certificate. And we've just seen, if we don't have a client cert, no IPsec, all right? CRLs are not checked by default for IPsec. What you can do is you can do strong checking in IPsec, in which case they are. If they are, you've got to make sure that all the clients, all the servers that are using IPsec can gain access to those certificate revocation lists. The wizard, step 2 of the wizard in UAG, it says what you need to do is you need to specify the root certificate of the client cert. All right? We need to install that into UAG. So if you've got a client cert out there and you have the root certificate in your root store, that's not enough. What we have to do is specify it to UAG itself, so it can check for IPsec purposes. Because what it needs to do is bind that certificate for the IPsec checking. We then need the HTTPS certificate for the UAG server itself, and obviously the client needs to make sure that they've got the, sorry, let's just go, the client needs to make sure that they've got the root certificate for that. So what I want to do is look at IP HTTPS scenario. So we've got a client, and the client is actually sitting on the home network, so the home network, and cannot get connectivity. And the reason it can't get connectivity is port 3544 is blocked. So it's not going to use Teredo. We've established that it can't use Teredo because UDP 3544 is blocked. So what it should do is fail over and use IP HTTPS. So we're going to start on Windows 7. And what we're going to do here is attempt to go to our corporate network, and it fails. Well, we've seen that one before. Okay, so we come up here, and we do an ipconfig/all. And with the immediate giveaway that we're on a sort of behind a NAT device is the mshome.net suffix. We've got a 192.168 address. That's being given out by the NAT device itself. So what I want to do is have a look, because what I would expect is the Teredo tunnel to come up. But the Teredo tunnel hasn't come up, and the reason is that 3544 is blocked. I know that, so what I would then expect is the IP HTTPS tunnel to establish. And again, that's not established itself. So what we can do is actually look at these tunnel endpoints and see what state they're in. So I can come up here, and I can actually do, on here is, well, let's clear the screen, get it up the top, and I can do netsh on here, and go to interface, and we can actually look at the interfaces. So if you need to do any troubleshooting, you can see the HTTP tunnel. This is the HTTPS tunnel. We've got Isotap if we're working inside CorpNet. We've got Teredo, and we've got 6-4 somewhere. There's 6-4 up the top. So we can actually go in and delve into all of this. I want to look, though, at HTTPS tunnel, and come in here, and I'm going to show the interface so we can actually see the interface itself, and I've got an error message. I've got OX8009230013, whatever that might be. And of course, the best way is actually to have a look on the internet to see if you can get a clue from that. But what I want to show you before we do that is that we can actually grab the URL. This is the termination. This is the tunnel termination on the UAG server. Let's see if we can go to it. Takes a while. There we go, which is pretty good, really. It's we have got to the tunnel endpoint, and it says the website declined to show the page. It means that we have an HTTPS connection through to the UAG server. It's an error message, simply that it's not a web server. But we have got the connection. And the other significant thing, looking at this, is there's a very good chance, unless I've fooled with my IE settings, that the certificate on the UAG server is valid. Right? Because otherwise, I would expect an error message at this stage. So if we actually go back and have a look at that error message, and we go and do a Google search on it, you will find something about CRL. So it is a CRL certificate error. So something's wrong with the ability to get to the certificate revocation list. Well, where is the CRL meant to be? So what we need to do is look at the UAG server certificate. And we can go back over here. And we can look at the certificate, which is da.example.com. And what we're looking for in here is details. And we're looking for CRL distribution points. And we've got two. We've got one, which is into our Active Directory, so we can pull it from that. Obviously, a DA client can't get there when it's outside. And we've got one here that we must be able to get to. If you can't get to it, we are never going to bring up the IP HTTPS connection. So we've got to make sure that we can actually get to that point. And it's very, very important that if you do your own certificates, you publish the distribution point external so the client can get it. So what we can do is actually test if we can actually get to that point. And I can just come up here and test that. Come on. We're not getting there. So that could be the problem. All right, let's go and actually go to our CRL distribution server. And what I'm going to do is actually start the servers because someone turned it off by mistake. All right, so the CRL server was there, but actually it can't serve out anything because the web service is stopped. So let's just turn on the web service. And let's go back to Windows 7. And let's do a refresh on that. So now we can get to the CRL distribution point. And this is always a very good confidence test in terms of troubleshooting. Got a problem with HTTPS? Can we get to the CRL distribution point? If not, we ain't going to get anywhere. So next job is to go back and try and actually what I'll do on here is I will just release my configuration, because remember I'm on the home network using DHCP, renew it, and I hope IP HTTPS will come up. So what we're expecting is the IP HTTPS interface to initialize itself, and actually it may take a few seconds. Let's try again. Still not up, and again, we'll just... Okay, one last try. There's all sorts of timing issues here, so I was just waiting. Here we go. There it is. It's up. And we've got an IPv6 address, and that is now initialized. So what we should do is we should actually be able to connect successfully, but we'll just show the interface. And we show the interface. Its last error code there is 0, which is fantastic. So it means it's active, and it says it's active. So what we should be able to do is go to our home page, which is inside CorpNet. And this actually, the troubleshooting problem that someone threw at me yesterday was exactly that. What they'd done is they hadn't published their CRLs externally. And I pretty much went through exactly the same sort of troubleshooting steps here. Our experience yesterday was this demo. It was just nice to see that the two tied up beautifully. Okay, another area of problem is client location. Right? The client, when it's out on the internet and it wants to surf something on the internet, what we will do is it will go to DNS and it will look up Bing, and off it goes to Bing. But when it wants to get a CorpNet resource, we obviously don't want to publish our CorpNet resource in our ISP's DNS. So we need to point to a DNS server internally. Now, this is one of the reasons you need Windows 7 or 2008 R2 as a DirectAccess client, because it has a thing called the Name Resolution Policy Table, which says where we should go based on name. So where should we go for DNS based on name? So this is the job of the NRPT. And if we look at the NRPT, what it's going to do is it's going to have an entry and saying, if you're going to something inside CorpNet, use DNS2. If you're going anywhere else, use whatever your current TCP/IP settings are. All right? Now, there is one special case, and this is a thing called the NLS server, or the network location server. We have a special entry in there, and we, rather than saying go look for it in Corp, we tell it to look for it through the DNS server that is configured in your TCP/IP settings. So if we're out on the internet, we will go to our internet ISP DNS and say, hey, give me the address of nls.corp.example.com, and it will go, what? Doesn't know the answer. So because we can't find nls.example, we assume we are on the internet. When we go inside CorpNet, it does exactly the same thing. But this time, we've got our TCP/IP settings from CorpNet. So we have a valid DNS setting. So now we go up to the DNS server and say, hey, give me nls.corp.example.com. It returns the IP address, and what we do is an HTTPS connection to it, and we say, we are inside CorpNet. And at that point, we drop our NRPT. The name resolution policy table is only used on the internet. So there's a picture of an NRPT. I won't discuss it anymore now because we'll see it in 1 second. So this web service, the name I've called it nls.corp.example.com, it can be called anything you like. It is just a web service that you say is going to be used for identifying whether the client's inside or outside. It needs to be highly available because if you can't find it, the clients will consider themselves to be outside of CorpNet, and you will get all sorts of funny connectivity problems. So if we can't find this guy, the NRPT is going to remain enabled. So I'm going to go and troubleshoot a DNS problem. I've got a Windows 7 client. He's sitting out on the internet, and he's all very happily sitting out there. And, sorry, excuse me, I've just lost the page I was on. Yeah, so, and what we're going to do is we're going to actually try and access CorpNet resources, and then we'll bring the client in onto CorpNet, and we'll see what happens. So Windows 7, we're starting off on here, and what I'm going to do is try and connect to CorpNet, and it's successful. So previously, it's always been unsuccessful. So we've successfully connected into CorpNet. This is the DA client. What I'm going to do is I'm going to bring this guy, and I want to bring him inside the corporate network. So in he comes. OK, so now let's go back to Windows 7. And let's try connecting to this Corp resource. It fails. Right. So what do we do? Well, we need to start troubleshooting it. So I'm just going to grab this guy again. And what I'm going to do is bring up a command prompt as usual, and we'll try pinging him. And just trim that off. OK, no DNS. So that's certainly what it implies is that we can't get to it. So let's do an ipconfig /all. And if we look up here, what we see is we got an IPv4 only stack. And this is how we wanted to design, because this guy always worked at a particular branch office, uses an IPv4 only on that branch office. Now, why don't we have a link local address, etc.? We look at our TCP/IP adapter configuration. What you'll see is the checkbox for IPv6 is clear. Now, all that means is with that box clear, it doesn't remove the IPv6 stack. It just means the adapter will not configure itself for IPv6, so we don't get a link local address or anything else. So we'll cancel out of that. And what we've got is we've got a DNS server, which we can see is at 10.20.100.10. So we've got a DNS problem. Favorite troubleshooting tool for DNS? Yep, NSLookup. So brilliant idea. Let's use it. OK, so it's resolved to gone to 10.100. The server unknown, by the way, is just because I haven't got reverse lookup on. So that has actually worked perfectly. So I've got an IPv6 address, and I've got an IPv4 address coming back from this guy. So let's grab this IPv4 address, and let's ping it. That works. Okay. DNS works. We know it works. We just use NS lookup. But that fails, and yet it worked inside. It worked inside NS lookup. Any ideas? Name resolution table. What a brilliant answer, sir. Let's have a look at it. So netsh, and what we're doing is name space show, or shoe if you like. Let's have show effective policy. And there it is. There's the name resolution policy table. Just to prove that it really is, we just go up a little bit. It shows it, okay? And what we've got in here is 2 entries. It says, if you're going to corp.example.com, go to this, use this DNS address. And the client has no capability of doing that because they've got an IPv4 only stack, and we haven't got ISOTAP running on our network. So there are no ways of transitioning to that. If you're going to nls.corp.example.com, use this IP address, which is your TCP/IP configuration address. All right. So that's telling us there's a problem here because the table's still up. And what we can do is actually look a bit deeper on here, which is a very, very useful command to actually look at the DNS client. And what we'll do is we'll show state. And it says, look, you're outside CorpNet. All right? So what do we think we're probably missing if we're outside CorpNet? What's it going to look for? Yeah, it's outside CorpNet. So the question is, can we resolve to the NLS server? And the problem is, actually, we can't because the NLS server is not available. And the reason is I stopped it. It was the easiest way of showing not availability. And we can see how important it is. So I'm just going to drop the client off the corporate network, pop him back on again. This is just to force him into action. Apply that. And at this stage, he should be able to actually, we need to go back to Corp. At this stage, he should now be able to resolve the NLS server, and he should drop his name resolution policy table. So let's have a look to see where this guy thinks he is. He says inside corporate network. It's a good sign. Okay, let's actually have a look at the table. The table's gone, all right? So now our DNS should resolve quite happily. So we've got the table's gone. So can we ping? Yes, we can, which is a good sign. And we can also resolve here, I'm hoping. Well, I'd be very surprised if we couldn't. Yes. So that is sort of what I wanted to try and do with the demos is actually just give you a sort of troubleshooting philosophy and a way of approaching troubleshooting in a direct access environment. So a lot of it is just standard TCP/IP troubleshooting, except you've got these extra little components like the name resolution policy table, like IPsec, like the fact you may not be able to ping IPv4, but you can ping IPv6. So lots of little components in there. Best way to go forward on this is to actually build yourself a test lab. And I would build yourself a branch network as well, if not 1, 2, or 3. And you can set up ISOTAP internally and really get a feel for how it all works. We've actually got a one-day seminar that we run throughout Europe on direct access, and it goes in great detail. If you're interested in trying to run that over here, I'm more than happy to hear from someone. So just email. You've also got my email address, so if you want to send me a quick email, I'm very happy to answer it. I'm also very happy to engage in a sort of consulting with your company if that's also what you want. So, one last thing to say. What's very important, especially, is we need to get, there's a sort of, number one, the evaluation is really, really important, especially to third-party speakers. Otherwise, you don't get back another time. It's terrible. But also, comments are very useful to me. I'll read every single comment and make a note of it and see how I can change things, address things. Or, you know, if you appreciate it, it's just really nice to see that as well. And also, please, please, please fill in an evaluation, because there has to be a critical mass before it even gets evaluated in terms of the system. So I would sort of ask you very nicely to please fill in your evaluations. And all I got to say is have a very safe journey back. I will. Who's going to the party? Oh, that's about 50%. So really enjoy the party. Have a safe journey home. And hopefully I will see you next year. Thank you.